Alright, what I have on the board, I know you guys don't have it, so don't look for this thing that I have. It's just that I'm going to use this to explain what we're going to talk about. I know that 3 times 4 is 12, right? That's something that we already know. But this, the 3 and the 4, this is what we call your factors. Right? So 3 and 4 are both factors of 12. But those are not the only factors of 12. I can also say 1 and 12, and then 2 times 6. So the 3, the 4, 1, 12, 2, and 6, they're all factors of 12. Right? So factors, once again, are the number that I multiply to come up, in this case, to 12. So let's take a look at our word. And let me make this a little bit smaller. For question number 1, it says list all the positive factors of 15. What we're going to do to start with, I know 1 and 15 are factors, right? Because 1 times 15. So matter of fact, 1 is the smallest factor, 15 is the biggest. So if you notice, I put my 1 all the way to the left, and my 15 all the way to the right. I left myself some space. After 1 is 2. Is 2 a factor of 15? No. Alright, after 2 is 3. Is 3 a factor of 15? Yeah. 3 times what? 5. 3 times 5. So notice I put my 3 on the left and my 5 on the right. So after 3 is 4. Is 4 a factor of 15? No. After 4 is 5, but 5 is already on my list, so I'm done. So my factors of 15 are 1, 3, 5, and 15. Right, this one, it's okay if we have a space in between. Notice my space I have in between, it's fine. I never said they have to be close to each other. It's okay if we have a space. Some numbers will have a few factors like 15, but 24, question number 2, 24 might have a little bit more. So I'm going to start with 1 and 24. After 1 is 2. Is 2 a factor of 24? 2 times what? 2 times 12, okay. After 2 is 3. Is 3 a factor of 24? Yes. 3 times what? 3 times 8, okay. So 3 and 8 are factors of 24. After 3 you get 4. Is 4 a factor of 24? 4 times what? 4 times 6. After 4 is 5. Is 5 a factor? No. After 5 is 6. 6 is on the list, so we're done. One thing, and I'm going in order. Notice I was 1, 2, 3 in order. As soon as one of our numbers is on the list already, we're done. Right? There's no other factors of 24. Keep in mind, I'm only looking at positive numbers, right? We can include the negatives and all that stuff, but only the positives for this one. Let's take a look at number 3. For 16, I'm going to start with 1 and 16. Is 2 a factor of 16? Yeah, 8. 2 times 8, okay. After 2 is 3. Is 3 a factor of 16? No. After 3 is 4. Is 4 a factor of 16? 4 times what? 4 times 4. I will write the 4 only once. Right? I'm not going to write 4, 4. I'll only write the 4 once. But since it already repeated, then I'm done with my list. So those are the factors of 16. Okay, so that's basically our 12th question, the first 12. I'm asking you guys to list all the positive factors of each. Any questions on the first 12? Alright, let's take a look at number 13. Write the prime factorization of each. Prime, what prime means, it's a number that its only factors are 1 in itself. Like 3, 1 and 3, 7, 1 and 7, 11, that's also prime, because 1 and 11 are the only factors. But a number like 20, for example, 20 is not prime. Right, so remember, prime numbers are the numbers that the only factors are 1 in itself. That's it. That's what a prime number means. So here, what we're going to do we're going to break this up. Give me any two numbers. They don't have to be prime, or they don't have to be the same. Give me any two numbers that multiply equals to 16. 4 and 4. 4 and 4. Okay. Let's make the 4 smaller. Any two numbers that multiply equals 4. 2 and 2. Both of them are prime, right? At the bottom 4, I'm assuming you guys will also go 2 and 2. Both of them are prime. So what I will write for my prime factorization, I'm going to write 2 times 2 times 2 times 2. Right? Product of prime numbers. If we multiply this, 2 times 2 times 2 times 2, it should be 16. So I'm multiplying prime numbers to come out to 16. That's basically what prime factorization means. Okay. Looking at 26, like question 14, but number 26, give me any two numbers that multiply equals 26. So 13 and what was it? 2? Okay. Hold on, this thing just froze for a minute. Alright, so there we go. 13 and 2. Can we break this more? They're already prime. So for the prime factorization, I'm going to go 2 times 13. We try to keep them in order. The smallest to large. Alright, so once again, we try to keep them in order. So 2 first and then the 13. 2 times 13. Take a look at number 15. So 28. Give me any two numbers that equals to 28. 7 and 4. And then I heard 14 and 2. Let me put it here at the side. 14 and 2. Because I want to see if we start with different numbers, if we get different answers. And by now, I'll tell you guys we shouldn't get a different answer, because like when I asked you guys, I said give me any two, because I said any two, we should get the same thing, but we'll check. Alright, so I heard first 7 times 4. I know 7 is prime. What about 4? 2 and 2. So if for this, what we will get will go 2 times 2 times 7. But let's say 14 and 2, right? The other case. I know 2 is already prime. What about 14? 7 and 2. If I put this together, do I get the same answer? I get the same answer. So it doesn't matter which two numbers you start with. That's why I usually come and say, give me any two. It doesn't matter which two. Alright, any questions up until 24? Yes. 16. Alright. Give me any two numbers that multiply equals 22. 11 and 2. Can we break either of those? So no, so we're just going to go 2 times 11. Right, they're both prime already. Once again, in my answer, my factors, basically the numbers I'm multiplying, should all be prime. Those are prime factorization. Any questions up until 24? One thing before I look at the next section, keep in mind that in the first numbers, in number 15, the same number repeated. So sometimes you have a number that repeats more than once. So for that, that's what we came with what we call prime factor, which is a prime power. Prime power starting number 25. 25 and 26, they don't really happen. So let me show you guys the numbers 27 and 28. For 27, give me any two numbers that multiply equals 25. 5 and 5. Can we break those even more? So before we will go 5 times 5, right? But for prime power, what it instead of writing the same number many times, use exponents. So this one I'm going to go 5 to the 7. Because I'm saying my 5 repeats twice. Instead of going 5 times 5, 5 to the 2nd. Kind of like earlier, we had a 2 4 times. Instead of writing 2 times 2 times 2 times 2, we could have written 2 to the 4th. But that's when we have prime power. That's what the power means in there. Looking at number 28, which is number 28, give me any two numbers that multiply equals 28. 4 and 8 is 32. 7 and 4, okay. Can we break down the 7? Well, 1 and 7, but we don't make it any smaller, so no. So 7 is already prime. Can we break down the 4? 2 and 2. So I have 2 2s and 1 7, right? So I'm going to say 2 to the 2nd times 7. Once again, we're using the little powers when a number repeats. If a number repeats, I'm not going to say they all have a repetition. That's why I skip 25 and 26. They don't have repetition. 26. If we look at 26, which two numbers multiplied equals 15? 3 and 5, okay. Can we break them more? So we're just going to write this 3 times 5, but none of them have powers because none of them repeat. Remember, we use the powers or the exponents when there's repetition. And none of these repeat. Let's take a look at number 30, which says 24. Give me any two numbers that multiply equals 24. 6 and 4, okay. The 6, we can break it up to what? 2 and 3. What about the 4? 2 and 2. So I'm going to come over and say 2 to the 3rd, because I have 3 2s. 2 to the 3rd times 3. Remember, we're using the powers only questions 25 through 36. If there's any. Any question? Which one? 22. For number 22, so number 20, we're not using the prime power, we're just using the prime factorization. Give me any two numbers that multiply equals 20. 5 and 4. The 5 is already prime, so we cannot break that anymore. What about the 4? 2 and 2. So here I have to go 2 times 2 times 5. And I'm not using power on this section, or at least on this part. Any questions? Number 31. Number 31. Number 31, we're using the prime power. So let's bring this up first. 5 and 6. 2 and 3. None of them repeat. I'm just going to write this as 2 times 3 times 5. None of them repeats. I'm not using any exponents. And once again, on the powers, we try to write, on the factors, we try to write it from small to large. Just keep an order from small to large. Any other questions? Let me take pause really quick.